We are going to study about lenses. You must have seen people using spectacles for reading. The watchmakers use a small magnifying glass to see tiny parts. Have you ever touched the surface of a magnifying glass with your hand? Have you tried to understand whether it is plain surface or curved? Or have you felt it is thicker in the middle or at the edges? Well, the glasses used in spectacles and that of a watchmaker are examples of lenses. What is a lens? How does it bend light rays? We shall discuss these in this section. If a piece of glass or other transparent material takes on the appropriate shape, it is possible that parallel incident rays would either converge to a point or appear to be diverging from a point. A piece of glass that has such a shape, that means a piece of glass which can converge or diverge the light, is referred to as a lens. There are a variety of lenses. Lenses differ from one another in terms of their shape and the materials from which they are made. Here you can see variety of lenses. The first lens you can see is having curved surfaces bulging outwards. It is known as double convex, or you can even call it as biconvex. Then here you can see a plane and a curved surface, and this is known as plano-convex. Similarly, here you can see two surfaces. This is also this one and this one. This is known as converging meniscus. Then this is a double concave, a plano-concave, and diverging meniscus. Now about construction of simple lenses. Most lenses are spherical lenses. Their two surfaces are parts of the surfaces of spheres. Each surface can be convex, that means bulging outwards, or concave, that means depressed inwards, or planar, that means flat. And you had already seen different kinds of shapes of lenses where you had seen the lens had a convex surface or a concave or a planar surface. The line joining the centers of the spheres making up the lens is called the axis of the lens. Spherical lenses are the lenses formed by bounding two spherical transparent surfaces together. So when you are talking of spherical lenses, they are formed by bounding two spherical transparent surfaces together. Those transparent surfaces are going to be of a sphere. In general, there are two types of spherical lenses. Lenses formed by binding two spherical surfaces bulging outward are known as convex lenses. Here you can see two spherical surfaces which are bulging outwards. This is a convex lens. While the lenses formed by binding two spherical surfaces such that they are curved inward are known as concave lenses. Here you can see a lens made up of two spherical surfaces which are curved inwards. Can you see this? This is curved inward, right? This is a concave lens. So basically we confine our studies to a convex lens and a concave lens. This is one of the basic difference between concave and convex lens, that is their shape. Now, convex lenses are also known as converging lenses, since the rays converge after falling on the convex lens. Whereas concave lenses are also known as diverging lenses, as the rays diverge after falling on the concave lens. Now, in the diagram, you can see that in the first diagram, you can see the converging action of the convex lens. You can observe that the rays which are falling on the lens after getting refracted meet at a point. They are converging at a point. Similarly, in the concave lens also, the rays which are parallel to each other are falling on the lens. After refracting, they are moving away from each other and appear to come from the point. So here it is converging, here they are diverging. So that is why convex lens is known as a converging lens, whereas concave lens is known as a diverging lens. Here you can observe the phenomena of convergence of the convex lens. You can see a parallel beam of light falling on the lens, which after refracting through the lens meets at a point. That means it converges. Similarly, here you can observe the diverging action of the concave lens. A parallel beam of light, when it is falling on it, it is moving away and appears to come from a point. So this is the diverging action of the concave lens. Now the converging action of convex lens and diverging action of concave lens can be easily understood by considering a lens as a series of truncated prisms. But before that, we need to recall that a ray of light on refraction through a prism bends towards its base. And when light falls normally on a glass slab, it passes undeviated. Now observe this. Over here, the convex lens has been subdivided. So if you see this, this is more or less like a prism in this manner, right? And this is also a sort of a prism in this way. And this is a glass slab. These are prisms with their bases opposite to the previous ones. Now, I made you recall that the light that passes through the prism bends towards the base. So you can observe over here that the light is bending towards the base. Same way it is bending towards the base, whereas over here it is going straight. So this way, when you are breaking up the lens into subsequent prisms, right, and a glass slab, you will find that it is helping this, the breakage is helping us to understand how the rays are getting converged at a point. Now you observe the concave lens. Over here, it is being broken. Like this is the picture of a concave lens. And when you break it up, then you get views like this. Now, here the bases are on the opposite sides. So when a ray of light passes through this, it bends towards the base. That means moves upward. Identically here also it moves where? Towards the base. That means downwards. So here you can see it is moving towards the base, and this light which is like passing through the slab is going straight. So they are appearing to diverge from this point. Now, it's only here to summarize the differences between convex and concave. Like convex lens converges a straight beam of light, whereas concave lens diverges a straight beam of light, which is shown in the diagram also. This lens, convex lens, is thicker at the center and gets thinner towards the edges, whereas a concave lens is thinner in the middle and thicker towards the edges.